This is ready for stropping. All right, now, this is a machine that I've been using since, I don't know, 1983, something like that. So 40 years. I built this because I couldn't afford to buy one. Maybe you can. You're welcome to. They're sold as lapping machines by a jeweler's supply company. You know, Guess Wine and others have these in their catalogs. I don't know, they're probably around $1,000 or something. But you can put one of these together for short money. There's 3 secret ingredients. One is that the motor that you use has to be a high-speed motor. So this is a motor with an RPM, which is the same in inches and metric, of 3,600. So it's 3,600 revolutions per minute. And then this is a lap, which I think you can read on it here. It says 100% wool, all right? And it also says crafted with pride, which, you know, hey, it's hard to read here, but this is the condition of the wheel, or the spec is, this one is called hard. So these are available from, I can't remember all the different grades, but there's a bunch of, there's softs and mediums. It's sort of like dynamics in music where there's a lot of them. So this is sort of mezzo forte. The fortissimo ones are like particle board. And I believe that the hardest one is called diamond hard, and it almost doesn't move at all. The softest one I believe is called soft. Again, I've never used them, but I've seen them in catalogs and on jewelers' benches, because this is a very useful tool to a jeweler, and this does a huge amount of polishing for any kind of jewelry making or refurbishing that you might do, right? This spins, like I said, at 3,600 RPM, and if we multiply that by pi and pi by the diameter, we get 7,500 surface feet per minute, which is really fast. And this is the speed that you would run a buffing wheel. Although, as I said, it's a lap, L-A-P. It's not a buffing wheel. And we'll provide a link to all of this stuff in here. But the 3 secret ingredients are high-speed motor, extra long shaft, tapered spindle, and an 8-inch diameter, tapered, which means the top surface is angled like this. Bottom starts out flat. Tapered, split, which means these 4 slots, and lap. So 8-inch tapered split felt lap, grade hard. And this is the one I recommend. I've been using these for 40 years. They're unbelievable. I've never seen anything work so well to put a perfect edge on a woodworking tool by creating a very small, sort of rounded micro bevel, a parabolic shape, okay? If you want, we can go through and, you know, do a step-by-step how you put one of these together, but there isn't really much to it. If we call this, you know, 21 degrees tilt, seems to be working pretty well. The reason that there's splits in the lap is that when the lap is running and you train a light on the top of it, you can see through the splits and you can see exactly what you're doing. And that's the secret of this whole thing. And that's why it's Buddy. And Buddy says dull tool is an oxymoron. So again, back to the beginning, sharpening is tricky, but it doesn't have to be hard. It doesn't have to be slow. And it certainly doesn't have to be inconsistent. And I think if you can get your edge straightened out and sharp, and then you have the services of Buddy, you really can't go wrong. I remember when we were carving the top for the blue guitar, I timed myself sharpening that convex bevel seriously improved gouge at 40 seconds from walking away from the bench to putting the gouge back in the wood. So if we can figure out how to do this right, sharpening is a lark, it's a break, it's time to, you know, stretch, think about something else for a second, and you walk back to the work with a tool that is just supremely sharp and will endure as long or longer than any other method of sharpening. So here we go. I use this finishing compound, which is a German compound by Menzerna. We can put a link to this, but I don't think it matters that much. All it has to do is be capable of buffing tough materials. What I used to have was a stainless steel buffing compound, and I guess this is not actually formulated for stainless steel, but I believe it is still formulated for tough materials, and that's the point. Tool steel is tough, and you need something kind of aggressive to cut it. What we're going to do is start the wheel. You do need eye protection. You don't need a dust mask. The light's going to come on automatically. We don't need to buff on the top of this, so we're going to just put the compound on the bottom of the wheel, and we'll be able to see through. And I'm going to make sure you can see this because it's just magic. Now, you can see the black buffing compound. And this is an interesting thing about optics and metal, okay? We've got a yellow compound, but you can see it's turning black. And what happens is the yellow compound is cutting the steel into such tiny particles that by the time the light reflects on these minuscule particles and has a 5% light loss every time it hits a particle, it all cancels out and comes out to nothing. Trust me on this. Anytime you buff something shiny, it'll come out black. So what we can do is we can see that means we've started touching back here at the back of the bevel, which we don't care about polishing. But what it's going to show us is where we are in an angular relationship to the bottom of the wheel. Now you can see I can lightly touch the wheel. It's actually polishing my fingerprints. I can lightly touch the wheel and it doesn't matter. So it's quite a safe tool. So I'm looking right through the wheel. And now I can see the buffing compound working on the edge. I'm using very light pressure. And now we have a mirror polish on this bevel, which just a second ago had 1,000 grit scratches in it, okay? So we know that an edge is made of two shiny surfaces, proper edge. We're going to flip this over. Now the last thing we want to do is blow away this beautiful flat surface we have. So we're going to use this trick of watching the compound advance along the back of the blade until we just barely get the compound to wipe off the end. And then we know we put just a little kick, a little bit of rounding to the very, very, very last few molecules on that edge. So we start out here so we know where we are. You know, we definitely don't want to do this by mistake, right? So we're going to err on the side of caution. You see that all right? So like I said, we're trying to keep this flat. Going to err on the side of caution. We'll polish the bevel again. So, case closed. I have just spent an awful lot of time doing this so that you could try and see what I was up to. But now I'm going to do it in real time with the other edge, and you'll see how long it really takes. So, seconds, right? Anyway, that's why we call this guy Buddy. Hard to do without it, hard to beat it, and simple. I will caution you, it can be a terrible, dangerous tool if you don't understand it, because if you were to place the blade in this direction by mistake, it would take it out of your hand and maybe do terrible damage to you. So obviously, that's why there's an arrow here. The tool has to be going this way, off the edge. If you were to get confused and turn the tool this way, it would take it out of your hand and cut you. So that's that.